I'm Chris Shufo with Extension Media, and I'm here with Kay Anamalai at Diodes Incorporated and their Paracom product line. We're here to talk about USB Type-C. We're just on the heels of the Consumer Electronics Show 2017, and USB Type-C is popping up everywhere. Kay's going to give us an overview of what it takes to build and power a USB Type-C system.
Sure. Thanks, Chris. Before we go into the building blocks that consist of the Type-C, I would like to highlight some of the key advantage of the Type-C. So the Type-C integrates data, video, and power over a single connector. I think that's the major advantage. And the second advantage is it's a very thin connector, like the Micro B connector. And the third advantage is reversible. Reversible makes it easy to plug the connector. So previously you have to properly orient the connector.
And it's always the wrong way.
That's right, it's always the wrong way. So now it makes it very easy for the user. So usability of the connector becomes much easier with the Type-C.
All right.
So, and because of its thinness, it can permeate across all kinds of platforms with a single connector. So previously there was a connector for a bigger platform, Type A, and then Type B for the smartphones.
Sure.
So we are able to unify it into a single connector.
All right.
So, and also it's scalable up to 20 gigabit. So that's a major advantage, anywhere from 480 megabit for USB 2 all the way to 20 gigabit for Thunderbolt. So we cover the complete spectrum over the Type-C connector.
So one Type-C connector and one longer, we'll talk about Type-C cable, can provide and replace multiple other high-speed standards.
That is correct, that's right.
So tell us about those.
Okay, so besides USB, we are able to transport DisplayPort up to 8 gigabit, which is DisplayPort 1.4.
Right.
And we are able to transport HDMI. HDMI is a popular standard for TV and multimedia applications, and we are able to transport up to 6 gigabit HDMI 2.0, and Thunderbolt we already covered up to 20 gigabit.
Okay.
So all those standards can be put over the Type-C.
In addition to USB 3.1 Gen 2, right?
Gen 2, which is 10 gigabit.
Right, okay.
That's correct. Yeah.
All right. So how do you implement USB Type-C? What are the key functions that one needs to design with this?
That's right. So I would like to go over some of the key functional blocks that is in the Type-C.
Okay.
One of the key functional block is the redriver. So Diode / Paracom, we are into the 4th generations of redrivers. So we implemented using silicon germanium technology. It is called the linear redrivers. Linear redrivers enables link training to go transparently over the redriver.
Right.
And another important benefit of our redriver is the channel loss. We can handle up to 36 dB of channel loss over our redrivers. So this is unrivaled in the industry. So that's the first functional block.
All right.
The next functional block is our crossbar switch. You know, the Type-C allows alternate mode. So besides the data, which is USB, we also allow video modes like DisplayPort or HDMI. That's why you need a crossbar. So the benefit of using our crossbar is the bandwidth. Our 3 dB bandwidth is like 8 gigahertz. So it allows transport of data up to 10 gigabit of data. So that's the second important functional block. The third one is the power switch. So power switch provides a lot of protection functions besides a low on resistance switching. So power switch is used both on the source side for charging and also on the sink side for charging. So both source and sink side, we need a power switch, and we incorporate all the protection functions. And as a result of the protection functions, you don't need external components to implement those protection functions. And we are also fast because of that. You don't need to track all those protection functions in the controller. So we simplify the functions of the controller by incorporating the protection functions into the power switch.
Okay.
And the fourth functional block is the transient voltage suppressors.
Sure.
So we need a transient voltage suppressors to prevent high spikes, high voltage, high current spikes. So we need a TVS for high speed signals like the data signals, and we need a TVS for the power signals. So in all those cases, we provide an excellent performance TVS products. So for the TVS, we handle for the power, we handle up to 40 volts of signal. We can handle 40 volts of spike on the power signal. And for the high-speed signals, we offer a low capacitance TVS. So we covered redrivers, we covered crossbar, we covered power switch, we covered TVS.
Right.
And the fifth element is the MOSFET. So instead of a power switch, you can also use the MOSFET, but you need the protection function to be incorporated into the controller. So we offer a low on resistance MOSFET.
Okay.
And the next component is our DC to DC converter. So our DC to DC converter is a flexible output DC to DC. It takes in the 23 volts from the source and provides up to 20 volts for the VBus.
Okay.
So those are the key functional blocks that is in the Type-C.
Right. Okay. So early on, you mentioned power delivery and powering
Yeah.
systems with USB Type-C. So clearly, something has to supply power to the entire system.
That's
What's
right.
that?
So that's the wall charger. So we offer a reference design for the wall chargers. So wall charger, we provide 3 functional ICs that goes into the wall charger. One is on the primary side, we have a switching mode regulated supply with a low standby power. On the secondary side, we have a synchronous rectifier, highly integrated with a low on resistance. And the third one is the Type-C controller with the integrated power switch. So those 3 components consist of the major functional blocks within the reference design for the wall chargers. Right now, we provide wall chargers for up to 15 watts, and we have wall chargers in development for higher rating as well.
So USB Type-C provides how much power in total
Good question. So we can provide up to 100 watts of power
with USB?
with the
Type-C
5 amps
connector.
and 20 volts. That's the 100 watts.
Yeah, that's a
So
substantial amount.
that's substantial over the existing powering, like the USB powering is a battery charging standard BC 1.2, which can only power 10 watts. So we provide a 10 order of magnitude improvement in power delivery with the Type-C.
I don't know about you, but I'm very excited to see USB Type-C ports on all my devices. I think it's going to be the digital standard for everything.
That's right. I
Yeah.
agree with you. Thank you.
Okay, well, so this is Chris Shufo, and I'm here with Kay Anamalai at Diodes Incorporated in the Paracom product line. We've been talking about USB Type-C connector and the electronics behind it, analog and digital. So Kay, thank you very much for your time.
Thank you for your time, Chris. Yeah, I appreciate that.
Okay, thank you very much.